outline of my presentation, the when's and the where to's, integrated biorefinery are the magic bullets, biorefinery and bioproducts, and some of the suggestions for us to move forward. The when's means that where are we from and where are we heading to? So this is one of the slides which I always share in my class for the past 10 years, 10 to 20 years. It shows the circle of life that we have to tell the students that we are very much intertwined and have very much close, intimate relationship with our nature. So if this is the circle of life, this is the source of life, then you can see that the two circles, if you disrupt one of the cycle, then the whole system will go haywire. So this is what we are seeing today when we disturb the the carbon dioxide emission, we disturb the water system and so on, then the whole system becomes haywire. This is another circle of life. So what we saw just now at the macro scale, now we are seeing it at the micro scale, or even at a much lower scale. And to show another interaction, which is very much intimate. So as you can see here, the red dot here, it can be any contaminants, which when they interact with our cell, if it's in harmony, then the whole system goes as planned. But if it's disturbed, then you can see mutation and disturbance in proteins, translation, and so on. So this is how all kinds of diseases start to take place, like cancer, for example. So for the past 100 to 200 years, we find there is a rapid industrialization. We have this type of setup close to nature, where this is the source of raw material. The cities start to be developed, and you have the water sources and so on. So the consumption, the consumers, the raw materials, and the production sites have now become common. So the industrialization has changed the way we live. So this is an example of what used to be a very green area by the seaside, now has been turned into integrated petrochemical complex. You can find this abundance in developing countries and also in the developed countries. So as a result of this, we find in the last 100 years, there is almost tenfold increase in carbon dioxide emission from fossil fuels. And the source of gas emission from the gas in terms of carbon dioxide takes almost 60%. Plus, so it's almost altogether about 80% with methane and nitrous oxide. And then the wastewater is only causing about 3% global greenhouse gas emission, but largely from transportation, industries, and also residential and commercial areas, also the energy supply. So if we don't do something about the way we manage our transportation, the way we manage our industries, this lot of greenhouse gas emission can keep on increasing, or even if it stays as it is, but the concentration will keep increasing in the environment. And also we have this recently published last 5 years on the greenhouse, that methane actually is causing more harm than carbon dioxide. It is 20% more potent than carbon dioxide actually to cause a global warming. But all the while we are concentrating only on carbon dioxide. So I think we need to do something to manage our methane emission also. And there are reports about most of these are actually involve flaring and to vent the natural gas, but those who are living, being reported last year, that those living near the flaring sites have the risk of preterm birth. We also have this problem with plastic, where almost we can see here an estimated a total of 270,000 tons currently floating in the world. And plastic debris is causing damage to the marine ecosystem. So this is another source of problems that we are facing apart from greenhouse gas emission. So we find this in Thailand. They have found that a whale had died from eating 80 plastic bags. And when they open up the stomach, they find tons of plastics, kilograms of tons of plastics. And also in Indonesia, also 1,000 pieces of plastic found in the stomach of the whale. In Malaysia, because of a rapid urbanization, we find there is a conflict with nature and also with animal kingdom. We sometimes build our houses and living areas close to their habitat. So we disturb their condominium and living habitat, and this is the result. And sometimes it's also deadly also, because they don't look left and right, they just cross the road, and then vehicle just, because we build our highways across their highways. When we build our highways, we don't have them in their mind that this is their highways. So I think a new way of thinking must be inculcated in the city planner, in the town planner, and so on, to get to involve and have this into their considerations. This is also another impact in Sumatra, especially, also Borneo, where the rural farmers especially burn the forest, because this is the cheapest and easiest way to clear up the land. So they burn the forest and cause forest fires, which affect also, especially this beautiful creature known as orang utan. So let us do some very quick reality check. There is a rapid temperature increase for the past 100 years. Between 0.4 to 0.8 degrees Celsius. And we are talking about controlling the temperature rise to below 2 degrees Celsius. So it's already nearly 1 degree Celsius now. There is an increased volumes of carbon dioxide and greenhouse gas emissions released from burning of fossil fuels and agriculture. Average global temperatures may increase to 6 degrees Celsius by 2100, rising sea level, severity of storm and severe weather patterns. And this combination of hunger, climate change, and man-made conflicts are creating a perfect storm for crisis. And Chinese Academy of Sciences is saying that the world's oceans are heating up at quickening pace, and the ocean heat waves has increased by more than 50%, which devastates wildlife and worse, and yet worse to come. So climate change affects crops quality and quantity, and there is increased desertification, especially in Arab countries. And the use of herbicides, widespread use of herbicides, has caused cancer-inducing and neurodegenerative diseases. Now, palm oil has been the important agricultural crop products for Malaysia, Indonesia, and some African countries. And now recently, EU has decided to phase out the use of palm oil for renewable energy. So this has caused concern among the growers and palm oil industries in developing countries, whether the EU stand is based on altruistic or is it based on commercial interest? Because if you have to remember that the oil from EU's like sunflower oil and wheat, all these are actually a part of their industries. So because palm oil on per hectare basis is more productive than all the other oils. So some of these concerns are being highlighted to the EUs, whether this is actually purely because of the climate change issues or because of commercial interests. Because the issues being raised are basically two. One is about deforestation, biodiversity, and environmental destruction. We can argue on this, and also about the saturated fat contents. But there are several scientific rebuttals have been made. So I will not address this now, but I'm just trying to say that these are all the issues that we are facing, that we have to be part of the solutions and not part of the problems. So if we want to create bio-based industry, it has to be part of the solutions. In terms of energy, it has to be clean for bioenergy, healthcare, affordable food, healthier food, high resistance and high yielding, and also cleaner environment and water, less toxic pollutants. So next, based on all this, where we are from and where we're heading to, I would like to present on the integrated biorefinery as the magic bullets to address some of the issues. So our previous presenter has highlighted on this. So there are 17 action plans proposed under Global Sustainable Development Goals. And when we talk about sustainability concept, we don't just talk about cost, about quality, about time. This is about what, 50, 100 years ago, you want to cut costs, you want to reduce time from lab to the market, and want to increase quality. But without looking at how you deal with your emissions, how you manage your resources, and how you manage your biodiversity, then you are no longer considered as sustainable in your approach. And even when you manage your resources well, you manage your emission and biodiversity well, if you don't look at the overall total environmental quality, the impact on the society, and also for healthier economy in global economy, then you are also not looking at things from a big picture and sustainably. When we talk about green chemistry, we want to reduce, as proposed by Anastas and Warner in 1998, stop wastage, safer chemicals and products, less hazardous chemical synthesis, renewable raw material, biocatalysis, less chemical derivatives. We maximize atom economy, safer solvents, increase energy efficiency, reduce the biodegradable products, real-time analysis, and minimize accidents. And green economy looks into this, use of biopolymers and bioresources. And the blue economy, we don't talk just about in terms of creating green battery, we talk about a system which do not need the use of battery, if it's possible. So there is a massive need for massive savings in material and costs, reducing the ecological footprints on the environment, and less health risks to the citizen, as proposed by Gunter Polly in 2012. So integrated biorefinery try to address all this by looking at the green feedstocks, transform the feedstocks into different products, green products like carbohydrates, lipids, proteins, lignin, and all these special substances. And each one has its own industrial applications like bioenergy, feed and food, for biomedicals. So in terms of microalgal integrated biorefinery, we are looking at the use of microalgae, not just for bioenergy, but also eventually to use it for other products, make use of, for, say, for example, for aquaculture, for example, and so also for high-value co-products. So Malaysia is the second world's largest producer of palm oil after Indonesia. This is in 2013, but the recent one is Indonesia is already nearly 50% now. So palm oil covers more than 30% of the world's total oil and fat. And oil palm is, in terms of biorefinery, Malaysia and Indonesia constitutes almost 80%. So just to abandon this based on EU directives, it will be catastrophic to developing countries. So it has to be a win-win situation where we manage our oil palm industries according to sustainable development goals, and also address the issue that has been raised by the EU countries, like how you manage your deforestation and so on. This is the example of oil palm trees, if you have not seen one. And this is the fresh fruit bunch, and each one contains, so you can extract oil from mesocarp here, and also from the from mesocarp here, and then this is the kernel, which is also the source of oil. And upon extraction, you get the empty fruit bunch. And this is the example of the processes from feedstock all the way to oil extraction and processes. So each part contains all what used to be called waste, and each one actually can be reutilized and reused for value-added products. So it's oil palm tree. This is so the government by 2020 last year actually plan to reduce methane emission, but because of the pandemic, I think there is a shift in goals to achieve this. But we have to manage the waste from free empty fruit bunch. And this is another example where we can achieve sustainable timber and natural materials from Ciba pentandra for the various types of usage. So the magic bullets involved in biorefinery, if we can address the bioenergy, we can address the bioremediation, biochemicals and biopharmaceuticals, bio-nanomaterials, and bio-nanosensor. So next, I will go into some of the examples of bioenergy and bioproducts very quickly. So this is our work with microalgae reactor engineering. We have grown in different scales. We have looked at the fatty acids for biodiesel. We have grown this in more economical media and seawater with a better effect also for bioremediation. This is just the biomethane from palm oil mill effluent. As you can see, palm oil mill effluent, when you want to improve biomethane emission for bioenergy, you can include some of these bioresources. And when you include microalgae in the POM treatment, you will find that there is higher biomethane as compared to without microalgae treatment. So biomethane actually can be converted to in liquid fuels. Although EU, I think next year, they have considered natural gas as no longer as green because of the CO2 release. But I think in the short term, because we still have to deal with abundance of methane, I think we can go for technology which from flaring and stranded gas to conversion into methanol, into diesel, and we can improve public health, because there are still, especially in developing countries, liquid fuels is still very much affordable as compared to electric cars. So you can turn this into all kinds of energy, but we have to develop the smart capture of biomethane emission and turn this into gas to liquid technology using heat machines. This is an example where conversion of biomethane or methane syngas into methanol, and methanol later can be converted through catalytic conversion to RON95 diesel or biodiesel. This is another product of ours which we make use of microalgae for anti-cancer agents. We have patented this, filed for patents. Three patents have been filed on this. We have developed functional foods from microalgae based on especially based on polyunsaturated fatty acids. This is antioxidants from microalgae, antimicrobial. So this is biopharmaceutical side, and the oil palm biomass itself can be utilized for different uses, like the previous presenter has presented. Like for example, bio-oil, biochar, biosorbent, activated carbons. And of course, each one, like lignin, hemicellulose, cellulose, has its own specific applications. At the moment, we have concentrated more on the cellulose. We have developed composite fabrication using cellulose and plastics, polyethylene. We have found that the tensile strength is very high with these composites. We have developed heavy metal organic pollutants removal based on magnetic biosorbent, also patent pending. Also cellulose based diesel desulfurization, also patent pending. And we developed cellulose hydroxyapatite chemical sensor, also patent pending. So there are, from where we are from and what are the problems, we propose biorefinery, and these are all the examples of bioenergy and bioproducts. Next is our way forward. So as you can see, there are rays of hope that some of this is taking place now. Like for example, even oil giants like ExxonMobil and so on have gone into green approaches. So what we need now is common platform and common effort to solve uncommon challenges, which I believe IAAM, International Advanced Materials Association of Advanced Materials, can provide leadership, if not collaborative efforts among members to develop this approach together and solve the common problems that we are facing. So EU-ASEAN partnership has been developed for sustainability, unregulated fishing, and so on. So these are some of the issues with palm oil issues. I don't think I want to go through. I think we can discuss this personally. But we can propose in terms of integrated bioprocess and bioengineering, nano-engineering. So this is the example of integrated biorefinery, a palm oil biorefinery involving palm oil mill and also microalgae for aquaculture, biopharmaceuticals, and bioenergy. And we have proposed this HASBA, which in Arabic stands for accountability towards sustainable living. which stands for health consciousness, environmental safety awareness, energy sufficiency, social inclusiveness, business acumen, and adaptability and agility. So this is the enterprise which we hope can be more, not just focused on profit, but also on social, entrepreneurship, and also using wisdom on how we manage our environment, our society, and so on. So what used to be, so this is just very quick. Shiba, we have Alibaba in China. Now we are proposing Hisba. I think this can be a vehicle for IAM also as the philosophy for us to develop. We can go for Hisba bioenergy, Hisba biomaterials, Hisba biochemicals, and Hisba education to go to educate the society about green approaches. We can develop sustainable agro-practices, renewable energy, green technology. We can go for ASEAN countries, Brazil, Russia, India, China, South Africa as the target countries, and also Islamic countries. We can develop mentor-mentee entrepreneurial development program and so on. We can discuss further on this, different types of activities. Some of these, like for example, the case studies can be carried out in Malaysia or in China and so on. So what we talk about is about blue, green economy conservation. This is some of our team which continue to do sampling and so on, but we have to deal with this not to remove from nature. So what we need is harnessing, not exploiting Mother Nature's bounty. With that, I thank you.